All right. Can everyone hear me? Perfect. Welcome to United Astronomy Clubs of New Jersey. We're here tonight live on site. We are also live streaming this on our YouTube channel. So you can, if you ever can't make it, you can always check us out on there. I also have chat up, so I will be monitoring our online chat during the presentation as well. While we get a couple people I noticed wandering down, let's go over a couple basics for our people here on site. So if you need to use the restroom, that is the porta potty off to my right, your left. We also have a little gift shop and museum area through the door to my left, your right. Tonight, it actually looks like hopefully we'll actually get some clear skies and be able to observe. I do notice we have a couple of the roofs rolled back on our sheds, which each of those buildings with the roll-off roofs houses its own telescope. So weather permitting, we will actually be able to look through them tonight. With not only, I think we might have a couple scopes where you can look through the eyepiece now, but we also have a couple where they're set up where instead of an eyepiece, we now have a camera attached, and that camera actually uses some astrophotography programs to then project that onto a screen so everyone can see it all at once. Couple more things to note. If you have a flashlight, please keep that pointed towards the ground. It just protects people's eyesight. No one enjoys being blinded. That being said, when we go to leave here tonight, please use your headlights. It's not great being run over, and we'd like to avoid that. Been there, done that. Would not suggest 0 out of 10. So, like I said, we are going to use our headlights when we go to leave. We are a nonprofit organization, so all your donations and the proceeds from our gift shop do go to keeping our lights on and offering these free public programs. That being said, you can also check us, for our online people, you can check us out on our website, uacnj.org. There you'll see a list of all our member clubs, as well as the types of telescopes we have, and all sorts of links and a list of our presentations. Like I said, we are on YouTube live streaming this, and you can also check us out on our Facebook, Instagram. We got a Discord server, Twitter, and I know there's one other one that I'm forgetting. I'm sure I'll get yelled at later for that. So, that being said, our presentation tonight is something I forgot. Carl, what is our presentation for tonight?
Taking a tour.
Yep.
To the universe.
Try now.
Is it on now? Let me see.
Okay.
Okay, it's on now, I guess.
It
There
helps
it
when
is.
it helps when we remember to press the power button. On the bright side, it was a simple fix. So our presentation tonight, like you said, is taking a tour through the universe. Karl Hricko has a doctorate in science education and has taught earth science at Carteret High School and astronomy at Union County College, Keene University, and Centenary University. He has worked on a project at the Space Telescope Science Institute at Johns Hopkins University to examine an alleged discordant redshift between the galaxy NGC 4319 and the quasar MRK 205 with the Hubble Space Telescope. Karl is a past president of Amateur Astronomers Incorporated, one of our member clubs, and as well as United Astronomy Clubs of New Jersey. He has been.
That's all. That's
Yeah,
enough.
that you've done so many things. The list is ongoing. And with that, here's our speaker, Karl.
Well, hello. Hello, everybody. I'm glad to see that all you did show up here, and looking forward to whatever presentation is being made. And I hope I can do the best job that I can in making the presentation. And we'll be taking a tour through the universe. That's hard to do, I know. The whole universe? Are you kidding me? Well, we'll do it in a virtual way, obviously. So here we are with the title, and in the title itself, in this frame, in this slide, you can see a galaxy. Now, this is the Pinwheel Galaxy. It's designated as M. Oh. Oh, okay. It's called the Pinwheel Galaxy, and it's in Ursa Major, which is the Big Bear, Big Dipper. And reason why I have it here in the title slide is because we can consider this galaxy as representative of our own galaxy, which looks something like this. And if we consider where we are relative to other objects in the galaxy, stars and possibly other planets, we're at the edge of the galaxy. And so we can take a photo of our own galaxy by simply looking into the other part of the galaxy, and you'll see those photos in future slides as I move this along. So this is kind of typical of what our galaxy would look like in the eyes of some alien coming in from outer space, coming into our area of space, in the outskirts of our galaxy called the Milky Way galaxy. So it's just typical. This is not the Milky Way galaxy. It's typical of our galaxy, however. Now, as you come up here, going to our tour, you pass by a sign coming in, introducing you to our area. We're in the State Forest, Jenny Jump State Forest, as you see over here, and we're going to our tour. And we're leaving, going upward, and as we do so, we can see the area around here from an aerial view, as you see over here. This is an old picture, but still, it suffices to give you an idea of how we look from the air to a certain extent. You can see where our building is, the main building, and behind the main building is our observatory. And the rest of the observatories are in that direction. You can see to the right of the image itself. Now, here we go, and the first object on our tour, of course, is the moon, which is about maybe 240,000 miles away from us. It's the closest. It takes about, 2 or 3 days to travel to the moon, so that's not too bad. If you forget your lunch, you can go back anyway and pick it up or whatever. You have some time to do that, unlike traveling to other kind of objects in our solar system. And beyond our solar system, as a matter of fact. And the moon is just waiting for us to get there. It's very happy that we're coming. Look at this image. Here's the front side and the back side of the moon. We see only one side of the moon because its rate of rotation is the same as its rate of revolution. So we see only one side as it moves around us. But it does spin at that rate. Moon does spin, rotates. Now you can see the difference. On the left would be the side that faces us, dark patches, craters, things of that nature. As a matter of fact, Galileo saw these dark patches. He thought they were areas of water. He called them seas, maria, they're called seas. And of course it was incorrect, but what did he know? That was the first time a telescope probably was pointed at any object in space. Galileo did it. Although he didn't invent the telescope, he used it to look at various objects in the sky, and the moon is one of them. Surprised to find out that there were blemishes on the moon, like the craters. Didn't expect that. Now, the one on the right is the opposite side of the moon. Photos taken by flybys and things of that nature. We haven't been there yet. But you notice that the dark areas are missing. So, for some reason, these dark patches, which were probably produced by impacts coming in from asteroids and maybe even comets, hitting the side facing us, causing the underlying rock to melt and come to the surface and produce those dark patches by not reflecting as much light as the other parts. You don't see that on the opposite side. It's quite different. So there's still mysteries about the moon to a certain extent. The moon has been plotted in terms of naming many of the craters that we can see. So there's a map of the moon. You can always check that on the internet if you're interested in looking at various kinds of structures and features on the moon itself. Now, How do we go to the moon? We've been to the moon in the past, although some people don't believe it. They say it's a conspiracy, and we've never been to the moon. But we have been to the moon. We didn't go this way, though. I can assure you of that. How we went is we went by a program that NASA developed. 3 parts of the program. The Mercury, 1 astronaut getting built up to having 3 go to the moon. Second program, Gemini, 2 astronauts. Third part, Apollo program with the 3 astronauts that did go to the moon. How many times? 6 times. So not many people realize that. This is part of our history. It's part of our history. Now, you can see down lower left the rockets that took up the various kinds of spacecrafts. You can see the largest one would be the one that took the Apollo program, the upper module or modules, to the moon. And there are 3 parts of this spacecraft. It's the part in front that has the command or the astronauts, the middle portion, which is a service module that has all the electrical and all kinds of supporting sort of features, and finally the end part, which is the part that separates and goes on the moon, the lunar module itself. Now these are the people that went to the moon. Neil Armstrong, you can see, left. First person on the moon, first human. Second person, Buzz Aldrin. Third person didn't go on the moon, stayed up in the service module and orbited the moon itself to keep things going, operating, and communicating between them and the Earth. So he never went to the moon. Collins was his name. Only Buzz Aldrin, by the way, is alive yet. So he's still alive. He's around here. Here's how they launched off on the Saturn V. And when they got to the moon, they did see Earth rise. Here's an actual photo taken from that area in space, from the area of the moon. You can see the moon's surface there, as a matter of fact. Beautiful picture of the Earth. Look at this. Earth rise. Imagine that. Imagine seeing that. Here it is a little bit higher in the sky. And then the 2 astronauts, Armstrong and Aldrin, separated out in the lunar module. And you're looking at the lunar module now. Who took the photo was Collins in the orbiting service module yet. So here's a beautiful image of that taking place. Landed on the moon. Of course, there was nobody there to take this photo. This is a photo of a later shot of the lunar module. But I stuck it in here just to indicate that they did land on the moon. Houston, the Eagle has landed, is what the story was. So we're getting a bit of history while going on this tour of the universe. And this is the history of us going to the moon, as I'm presenting here. And you can see the idea being that the first person on the moon was Neil Armstrong. Now, this is a common photo. You probably saw this in the past. And many people think this is the photo of Neil Armstrong stepping down the ladder onto the moon's surface. But it's not. Neil Armstrong had the camera. He went down first, never got his picture taken. Never got his picture taken going down the ladder. He took a picture of Buzz Aldrin stepping down, and that's Buzz Aldrin on the ladder, stepping on the moon's surface itself. And this is the only photo of Neil Armstrong on the moon. The only photo. And there he is, all the way on the right side. You can see. With his back turned to us. So, unfortunately, for whatever reason, only one photo of Neil Armstrong on the moon itself. Here's a photo again of Buzz Aldrin. In the visor, you see a reflection of Neil Armstrong taking the photo. And later on, what they did is, on the later Apollos, 6 of them went up. On the later one, they brought this rover, the lunar or moon buggy, to make it easier getting around the moon, collecting different kinds of specimens of rock, things of this sort, and laying down different kinds of scientific instrumentation. As a matter of fact, they did leave instrumentation on the moon. They left a flag for each time they went. So there's 6 flags on the moon, photos of which have been taken and can still be taken by the Lunar Reconnaissance orbiter that's orbiting the moon, taking photos of the moon still at this point. And so it has photos of the flags on the moon. So we've been there. No doubt about that. Six flags planted, as you saw. And collecting various kinds of rocks and also laying down instrumentation. They left a mirror, a special mirror on the moon's surface so that various observatories on Earth are involved in the program, forming a network, shooting a laser to the moon, bouncing off the mirror in order to determine a more precise kind of figure of how far away the moon is from us and the fact that it's moving away from us gradually, by the way. So we're going to lose it for a while. Then it's going to bounce back because of gravitational attraction, but it'll be moving away from us, and I would imagine it's going to have some effect on tides and things of that nature to a certain extent. I don't think we have to worry about that in our lifetime, though. Don't worry about it right now. So here they're returning back to the LEM. There's one of the legs of the lunar module, the LEM. And this is actual liftoff. They left behind a camera to take the image of it blasting off back to join the service module and Michael Collins on board the service module, still orbiting the moon. Then they came back to Earth, splashed down in the ocean. That's how they returned. And these were the last three people on the moon. Last three on the moon. You can see Schmidt, Evans, and Cernan. Schmidt is still alive, by the way. He's the only civilian that went to the moon. He's a geologist. And I suppose they wanted him to go because he was able to select the rocks that would be important for the various geologists on Earth to analyze. And they found out that the rocks had a different percentage composition than rocks on Earth and were as old as they figured the moon to be. So this is other evidence that we've been to the moon, the idea of collecting these pounds and pounds of moon rock and bringing it back to Earth again to analyze. Now, here he is, Eugene Cernan, the last one. Now, we're going on our tour, leaving the moon, going out to visit the whirling planets. And now, of course, 8 planets or 9 planets? Well, Pluto is still a dwarf planet. So the word planet is still there if you want to consider Pluto as one of the planets yet. So here they are. I want to show 8 over here. Idea being that the sun provides heat and light to us, and the sun has all kinds of tremendously strong magnetic fields around which different parts of the sun, the plasma on the plasma would be electrified gas, so the hotter areas made of plasma, the 4th state of matter, and other parts are made of gas, the 3rd state of matter. But here's, you can see this, it's taking the shape of the magnetic field that's curling right above the sun. Sometimes they break off, come towards the Earth, and cause the various effects like the northern and southern lights, for example, influencing our transmission of communications, affecting our electrical grid system, and so on, by these things breaking off the sun, coming in our direction, and bombarding us. Here's a sunspot, and you can see the lines that represent the magnetic fields on the sun, very powerful. And as I said, the sun provides us with heat energy. Its gravity holds in the 8 planets. Here's the planets again. See them all lined up going around the sun. Now here they line up in a kind of collage, left-hand side beginning with Mercury. What's next? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus or Uranus, depending on your preference, Neptune, and, geez, I chopped off Pluto. I cut off part of Neptune too. So Neptune isn't losing part of itself. But what's interesting here is that it only shows Saturn having rings. The other 2 large ones, now being called ice giants as well as gas giants because they're cold, would be Uranus and Neptune. They have rings, but not too visible from Earth. It took a flyby to pick up the idea that they have rings as well. So these planets have an atmosphere mostly of methane, ammonia, water vapor, uh, hydrogen and helium, nitrogen thrown in some of them. And their moons, of course, have the same. But they weren't always in this order. Since the beginning of the solar system, when it first formed, it's believed that they had a different order. They were bounced around back and forth. We may have lost a couple of planets being bounced out into space. Right now, other star systems have planets that were bounced out of their system and are floating freely in space. They're called rogue planets. They're not going around any sun. Interesting. First planet, Mercury. Very little of an atmosphere. Some sodium, a little bit of helium, and hydrogen. That's about it. No moons. It's the fastest of the planets because it's closer to the sun. And you get slower and slower the further out you move. I just dropped something here too. Wait a second. This is a short one. Okay. And so you have Mercury then being the fastest. No moons. It's not the hottest, by the way. The hottest is what you see here. Venus is the hottest. Why? Well, Venus is the hottest because it has an atmosphere of carbon dioxide, which is acting as a greenhouse gas, as it usually does, and it's holding in the temperature to the point where it's the hottest of the planets. It has no moons as well. And it has the same amount of, well, even though it has carbon dioxide, very little of it. So it has a very, very thin atmosphere. Not hospitable. Don't buy timeshare there. Not good. Next, our beautiful planet. Won't have to say too much about it. You should know about it at this point. Hate to bypass it, but I will. Here comes rising. Rising, next planet, Mars. Mars has always been looked upon as being the kind of interesting, strange mystery planet. A lot of stories have been written about Mars where we have aliens coming from Mars, invading the Earth, and things of that nature. And that's because of the fact that it was looked upon as being a mystery planet. Stories are made up about it since one of the astronomers thought there were canals on Mars. And from that point on, people picked up the idea that, well, how did the canals get there? People must have built the canal, some kind of aliens. And so there must be life on Mars. We don't know at this point if there's any life on Mars. Suspicions are there, but no evidence yet. No definite evidence. So it's the red planet because it has a lot of iron, and iron oxides produce a kind of reddish color. So it's a rusty old planet. Now, here's some of the stories that are written about Mars with it's always some kind of malevolent creatures on Mars invading us. And the one involving where they landed near Princeton, New Jersey. You heard of that one? War of the Worlds. Orson Welles did it, and H.G. Wells, his relative, wrote it. Well, there's always been a mystery about Mars. NASA picked up this photo. What does that look like? Your imagination carries you away. The brain is always trying to make sense out of what you see in shadows and things like that, which may not be there at all. But the brain tries to make sense out of things. And people have looked at this and interpreted this to be a face, a face on Mars. Check that out sometimes on the internet. Well, a little closer picture. Uh-oh. Did some alien civilization leave behind some kind of artifact for us to find and realize that they lived there at one time? Well, NASA sent up another flight, got better photos, and realized that, wait a minute, it's our brain working overtime. What we have here is really geological features in a kind of plateau area of Mars. It's like when you go to visit some national park and there's a profile of some president or something of that nature. Is that the president? And did someone make that profile? No. In any case, but we got some meteorites from Mars. Meteorites from Mars. Now, every so often they get hit off the surface of Mars, go into orbit there. We come close enough to Mars to pick it up in our gravitational field, comes falling down after a while, mostly in the Antarctic area, easy to see against the background of white snow and ice. And so we picked up some of these meteorites. This one here, by the way, was sliced open and was viewed through an electron microscope. And when they did that, lo and behold, wow, what does that look like? Like some kind of biological organism, has biological symmetry, one side looks like bilateral symmetry, one side looks like the other to a certain extent. Looks like a wormish sort of organism. And the team that did this, the NASA team, by the way, and they had a conference on TV afterwards indicating that they thought there might be a possible fossil remain of a nanobacteria from Mars. But no one has proven that yet, because usually when a team comes up with some kind of finding of that nature, they wait until the second team comes up with the same idea and shows the same thing. No other team has come up with the same kind of interpretation of there being a fossil like this, a nanobacterial fossil. So we're not sure. Bottom line, mystery, mystery. We do know that there is water flowing beneath the surface of Mars, salty water, brine below the surface. And we do know that on Earth, there's a lot of organisms, extremophiles they're called, that live in all kinds of weird conditions. Different pH in terms of being acidic or basic, different kinds of temperature ranges near hot geysers, in ocean vents, and things of this sort. So there's all kinds of extremophiles that live on Earth that could possibly exist under conditions that we might find on other kinds of exoplanets, maybe even the moons, maybe even Mars. We don't know that. And as we move along, the next planet, of course, is Jupiter, the biggest planet. How many moons? At last count, they're still counting the moons. 79 moons on Jupiter so far, as I got off the internet recently. And the bands indicate all kinds of weather conditions, winds, and things of that nature. And it has the so-called red spot, which is a giant hurricane supposedly going on Jupiter continuously for quite some time, as a matter of fact. And I mentioned before the atmosphere of these gas giants and these ice giants, mostly methane, ammonia, water vapor, hydrogen, helium, some nitrogen sometimes, stuff like that. You can see the red spot, and you can see a comparison of that red spot with the moons that Galileo saw around Jupiter. Of course, they weren't that large, so his telescope, he had about a 20-power telescope, and so he barely saw the moons, but he did see them. He thought they were stars first, because at that time, everything revolved around the Earth in the minds of many people. And so to find something revolving around something else, not a good idea. So he spotted them, and he realized they were moving around Jupiter. They couldn't be stars, which he named the Medici stars after his benefactors. But then he realized they weren't stars, and so he's, must be some kind of satellites moving around Jupiter. And they were named the Galilean satellites after him, but then given their own names. The closest one is Io. It's so close to Jupiter that it's being torn inside out. So it has all kinds of lava on its surface as a result. Very hot, obviously. Io. Next, Europa. Europa has what seems to be a covering of ice. Those are cracks in the ice that you see, those lines on the surface of Europa. And they believe that there's an ocean of water underneath, possible existence of life. NASA had plans to send some kind of probe up there, but they didn't get around to it yet. But it's on their drawing board. So in the future, you might find out there's life existing on some of these moons going around Jupiter, maybe even Saturn as well. But in any case, the next one, Ganymede, the largest moon in our solar system. Same idea, ice on the surface, maybe water beneath it. Largest. And finally, the last of the Galilean moons would be Callisto. And you can see the same kind of an effect, but there's all kind of pockmarks in this ice, been heavily bombarded. And by the way, you want to remember the names is I enjoy good coffee. I for Io, enjoy Europa, good for Ganymede, coffee, Callisto. I enjoy good coffee. Ah, what's next? The ringed planet, the beauty of the rings of Saturn, which has the most of the moons, 82 moons so far. Last count. Still counting because they're finding a lot of the satellites in the rings, embedded in the rings of Saturn, and so they're hard to find initially. Those many moons and the same kind of atmosphere. Next, you have the moon, the largest moon of Saturn, Titan. Next planet, Uranus. You can see it. A lot of nitrogen, so it's kind of fuzzy, not too clear. It has a large moon by the name of, you can see here, Titania. Titania. Here it is. Next planet, Neptune. A lot of winds, high wind. I forgot something. Uranus, something very important and interesting. It's the only planet in our solar system that's tipped over on its side, rotates on its side. And there's all kinds of hypotheses in terms of how that may have happened. But strange, it's rotating on its side. And it and Venus are the only two that have what they call retrograde motion, which means rotating opposite to all the other planets. Venus and Uranus. And Uranus on its side, as I said. And Neptune has a large moon as well. Triton. Uh-oh. Is it a planet or not? Well, flip a coin. Some say yes and some say no. There's still those that say yes, by the way. Well, it's being called a dwarf planet, right? And so a dwarf planet, you're still calling it a planet to a certain extent. And here's an actual photo, obviously, of Pluto, the furthest of the objects which was originally a planet. Now it's a dwarf planet. Also called the KBO because it's in an area beyond Neptune called the Kuiper Belt, named after the guy Kuiper, who discovered it, Kuiper Belt. And Pluto seems to be in the Kuiper Belt, which is probably one of the reasons why they kicked it out of the Major Planet Club and made it a dwarf planet. That's Pluto. But something interesting. It's the slowest, by the way, of the planets moving around the sun because it's the furthest. Something interesting, though. They discovered that it has moons going around it. 5 moons. Nix, Styx, Hydra, Kerberos, and Charon. 5 moons going around Pluto. But yet, it's a dwarf planet. It has more moons than the other planets that are in our solar system. Here's an interesting comparison in terms of scale. You can see the sun compared to the other planets. Look where the Earth is on the far right. Wow. That small size compared to the sun. You don't get the picture unless you see a scale model like this. Then you realize the sizes of things relative to each other in our solar system. Now, as we go out further on our tour, we go looking back at the solar system. We can see there's a ring of objects between Mars and Jupiter, known by the name the asteroid belt. Right, the asteroid. Some of them get sort of pulled away from the belt itself, come toward the Earth, and become potentially hazardous objects. Got to watch out for those. Anyway, that's where they are mostly, in that belt between Mars and Jupiter, sometimes coming to the Earth and causing some problems on Earth. Here's an image of one of the asteroids. You can see it doesn't have enough mass to have formed into a spherical shape, so it looks like a potato. I guess most of the asteroids are potatoes. Mars, by the way, Mars 2 moons, Deimos and Phobos. Phobos being the larger of the two, look like potatoes because they think that they have been captured from the asteroid belt. Because don't forget, it's between Mars and Jupiter. Now, we have the idea of different kinds of meteors that come from the asteroids. That's where they come from. The large chunks of rock that come, don't burn up completely, come and hit the Earth, come essentially from asteroids, chipped off the asteroids. So if the asteroid has a composition that's stone, then we get stony meteors. If it's a composition that is iron, we get iron meteors. If we get a combination of the two, we get the stony irons. If there's carbon in it, then it's a carbonaceous type. But there's also a type that has little glass particles called chondrites in it. And they would be chondritic kinds of meteors. So there's all kinds of different types of meteors that hit the Earth. And by the way, you don't see a meteor in space pretty much because they don't reflect that amount of light. And they move very quickly. When we see them, they're moving through our atmosphere already. And they're moving very quickly. So we only see meteors coming through the atmosphere. They move very, very quickly. Unlike comets, which move very slowly because they're way out at the distance of where the planets are. For example, Mars. So those are the meteors. Now, the comets themselves, most, you can see, have two tails. One is made of dust that follows the trail of the comet around the sun, its path, and the other is an ionic tail of gas, and it follows the magnetic field of the sun, actually. So usually you can see two tails, like on this one here. The yellowish would be the dust, and the bluish would be the ionic tail of the comet. We can see them moving in the sky very slowly, night by night. They don't streak across the sky. Comets can't streak across the sky unless they're coming into the atmosphere. Then it's too late. You may not even see it. It happens so quickly. Boom, you're gone. So we see them in space, really. That's how we spot them. Slowly, night by night, they move slowly, comets. Now, when they do that, they leave behind some of their dust particles from their tail. And when that happens, it leaves a trail of these dust particles that the Earth passes through occasionally. And when the Earth passes through that, I'm coming to it. I didn't get there yet. It leaves behind a meteor shower. That's what a meteor shower is, and you'll be seeing it shortly. Here, what I'm showing is where the comets come from. Two areas. A nearby area, which is not that nearby, but relatively speaking to the other area it is. It's the Kuiper belt, which I mentioned before, beyond Neptune, in which Pluto is located. The Kuiper belt, which is about maybe 40 to 50 astronomical units, AUs, the distance between us and the sun. So it's about 40 or 50 times the distance between us and the sun, which is about 93 million miles. Multiply that by 93 million miles, and you get where the Kuiper belt is. And so that's where some of these are coming from. And others come from further on out in a cloud that surrounds the whole solar system called the Oort cloud. So if it comes from the Oort cloud, they're long period comets. It takes a while for them to come back again. If it's the other one, Kuiper belt, short period comets. So we can tell then where it comes from in terms of if it's periodic or not, or what kind of period it has, long or short. Now here's a meteor shower. This comes, as I said, from the dust left over from the comet. We only see them when it comes to the atmosphere. They can zip along because they're in close. We can see them move across the sky very quickly. They're not shooting stars. They're not falling stars. They're small dust particles, little dust particles, maybe some as small as a piece of ash coming through the atmosphere, burning up, looking like a star that's falling. But stars can't fall, obviously, in that fashion at any rate. Dust particles coming through the atmosphere. Meteor shower. Sometimes these comets and objects come into our atmosphere, and they're large, traveling at a high speed. And as a result, boom, they blow up in the atmosphere like an atomic bomb. One happened recently, by the way. 2013 in Chelyabinsk, Russia. I don't know if you saw this. Check it out. Check it out. Someone had taken pictures. They had one of their phones in a car, took a picture of it streaking across the sky before, It blew up in the atmosphere like an atomic bomb. It tore off roofs of houses, shattered glass, sent hundreds of people to the hospital. Chelyabinsk, Russia. Just happened. So these things are coming in continuously, on and off. We've got about 18 meteors coming in per day, but very small. They burn up in the atmosphere. They come down as dust, mostly. But this happens occasionally. They blow up in the atmosphere. One did blow up as well in 1908 in Tunguska, Siberia. Blew over trees all around. Here it is. Good thing no one was living in that area at the time. So these things do occur. Here's a meteor crater in Arizona. I'm sure some of you have been there. But that's interesting. If you haven't been there and you're in Arizona, check this out. Very interesting. It's about maybe, about a half-mile deep and about a mile wide, something of that nature. Arizona crater, meteor crater. Barringer would be the family that owns the property on which the crater is located. All right, here we go. Out beyond our solar system into where the stars are. This is a nebula, a mass of dust and gas, which happens to be located in Orion, the Hunter constellation. So it's called the Orion Nebula. It's a birthplace for stars, a nursery for stars being formed. Stars are forming right now. Stars die. They're dying right now. So stars have a birthplace and a dying place. Here's a birthplace for stars, the Orion Nebula. Nebulosities can be either the nurseries or the cemeteries of stars, either one, depending upon what stage the star was in at the time when the nebula formed of dust and gas. This is also in Orion. Anyone see any kind of figure of maybe some kind of an animal in here? There's a big bunch of dark dust. And by the way, stars form better in a cool area. That way it doesn't mess up the formation of the star in terms of its nuclear fusion going on, causing it to, in quotes, ignite. This is in Orion, and it's called the Horsehead Nebula. Looks like a dragon to me, or maybe even a Loch Ness Monster, I don't know. But anyway, it's nice to see it through a telescope. It's not visible to the eye, but a beautiful thing to see, obviously. Again, birthplace for stars. Another birthplace. Look at this. These are called the pillars of creation. The Eagle Nebula, located not in the Eagle, but in Serpens constellation, the snake, wrapped around Ophiuchus, if you had your astrology sign changed recently. But anyway, it's in Serpens, the constellation Serpens. But you can see stars are forming right now in this. You can see them popping off of those towers of dust and gas. Look at that. Wow, fantastic. Now, this is the opposite. Cemetery. A star now has given off its outer atmosphere. Boom. It just blew out its gas, and it's expanding as time goes on. This is the Rosetta Nebula. Rosetta Nebula. Interesting kind of thing. Dying star. You're looking at a dying star in this photo right here, right now. It's in the constellation Unicorn, called Monoceros. Mono, single, Ceres or Keras, horn, single horn unicorn. Monoceros. Now here's an interesting one. This star blow up is expanding, and Hubble has been taking photos, sequential photos of it as it expands, and the star is still in the center of it. It happened to be a massive star that has collapsed into what is now a neutron star, which is revolving like a lighthouse, beaming out its energy source like a lighthouse beams out light. And as a result, it pulses. We can get the energy coming as it spins, and the beams of light come out from its poles. So it has been named Pulsar, These types of stars and neutron stars that revolve in this way, spin around in this way, I should say, are pulsars. There's a pulsar in the middle of this called the Crab Nebula, located in Taurus the Bull. Very interesting kind of nebula. Now we go on further on our tour, and we come across star clusters all over the place. Here's an interesting one. It's Omega Centauri in the constellation Centaurus, obviously, and it appears to have been a dwarf galaxy next to our Milky Way galaxy, and we simply absorbed it. We cannibalized it, stripped off the dust and gas from it, leaving behind the stars which now form the cluster. And it appears that maybe some of the other star clusters are remnants of dwarf galaxies absorbed by our Milky Way galaxy. Interesting idea. Now, here's an image of our own Milky Way galaxy. How is that possible? Nothing has been out there to take that photo. But as I mentioned before, we're in the suburbs or the outskirts of our own galaxy in one of the arms. And so looking back at the galaxy, we can get most of the galaxy in the photo. And that's what's been done over here. And that's ours. Now, in our galaxy, going around those stars, we've been finding exoplanets. Extrasolar planets, exoplanets. Some are habitable, or have the potential, I shouldn't say they are habitable, have the potential of being habitable planets, and others are not, depending upon where they are relative to distance from their sun and their makeup. Here's an example of some of the potentially habitable planets, which are located in what they call the habitable zone, or the ecozone, or the life zone. And that's the zone where water can be in liquid phase. Not that there's life there necessarily. I hesitate to call it habitable zone for that reason. I can call it an ecozone, but it just means that water exists in liquid form. Possible. Now, we discovered that around our closest star, the Centauri system of stars, Alpha, Beta, and Proxima Centauri on your left, see them there. The closest one to us, proximal to us, is called Proxima Centauri. It's a red dwarf star. It has, they discovered, 3 planets going around it. And one of them happens to be Earth-like. Here it is, a comparison. It's Proxima D. Now, of course, they didn't take this image. Artist's conception, how it might look. But according to how they have interpreted the information they've gotten, it has the same size as the Earth and presumably the same mass, not knowing what the atmosphere is at all. But it has the potential of being habitable. And here's an artist's conception of what it might look like from some other planet in space looking out at your sky. Another image that's taken, or drawing. Now, here's a beautiful shot of our Milky Way galaxy as we leave our own galaxy, going on our tour further out in space to see other galaxies besides our own. There are billions of galaxies in our universe. We're just one. We have billions of stars in our galaxy, and billions of galaxies containing billions of stars in our universe. And now they're saying that there might be more than one universe, multiverses. Wow, what a big world. Oh, hardly imaginable. In any case, though, here we are looking at our own Milky Way galaxy. Beautiful shot, beautiful. As we go out, we can see that there's a lot of interaction going on between the galaxies. Some are merging. As I mentioned before, some of the star clusters were originally dwarf galaxies absorbed by us. Some are merging, coming close together, pulling in material from the other one. Here's the large one pulling in material from the small one. This is the M51. M for its cataloging symbol system for Messier, the guy who collected a lot of these things, thinking they were galaxies, but weren't. They were really nebulosities. And so he made up a whole list of things on that basis. In any case, there are 2 galaxies here, you can see. You can see that they form this kind of interacting system. The whole thing is called a whirlpool galaxy. I looked at it through a telescope and through my small telescope, and I saw two eyes looking back at me. That's how it looks. That's how it looked to me through my telescope. Two eyes looking back at me. So it's interesting to spot if you have a telescope. Oh, by the way, it's I believe it's in Ursa Major or nearby, off of the handle of the Big Dipper, Ursa Major. Now, oh, here's a beautiful one, and interesting in the sense that it has absorbed other galaxies already, so has become quite large as a result of that. And you can see above it and below it two smaller dwarf galaxies that are slowly closer and closer to it to be absorbed eventually by the Andromeda Galaxy, M31. And by the way, it's attracting us toward it. And we're supposed to be absorbed and merge with it in, set your watches, 5 billion years. So by that time, we should be absorbed by the Andromeda Galaxy. Now, what about living in space? Can we live in space? Well, look, we had an astronaut on board the space station for about a year, right? So it's possible, but we have to make sure that they exercise and do things necessary to be in good health while being in a condition of microgravity, because our bodies have evolved in the sense of accommodating to the gravity on Earth. The gravity on the moon is 1/6 that of the Earth. So if we go to the moon, which I'm planning to do, have to take that into consideration. Divide your weight by 6. That's how much you would weigh on the moon. Going to Mars, it'd be 1/3. Divide your weight by 3. That's how much you'd weigh on Mars. So we have to be aware of this, and we have to make sure that we maintain our physical condition in going out into space, and maybe even setting up an outpost, a colony, or a settlement on either Mars or Mars and the moon. So we've been in space station, and here's an image of some of the astronauts on board the space station. They've got different kinds of research things to do. And by the way, interesting things about the space station, it's a wonderful scientific platform, science platform in space. They just sent up a bunch of stem cells. It seems stem cells can develop a lot better in a microgravity situation than it can on Earth. So it can develop into tissue, into organs, transplant, etc. In space, under microgravity conditions. Also, different material things are developed. For example, fiber optics. The quality of fiber optics becomes improved under conditions of microgravity. So things of that sort are taking place on a space station. Another thing recently, check this out on the internet. The fifth state of matter. How about that one? Fifth state of matter. The Bose-Einstein condensate, BEC, hypothesized by Einstein and Bose. Bose-Einstein condensate. Fifth state of matter. Negative mass. Negative mass. Made on board the space station. They sent up a special refrigerator. Refrigerated it in space. Have to have space to help too. Bring down the temperature close to absolute zero, which was necessary to make the fifth state of matter. Wow! Necessary for future space travel? Some scientists have connected it to the possibility of developing warp drive needing negative mass to do so. Wow! Connect the dots in the future. Anyway, we've been in space on the shuttle, going to the space station. We're developing various kinds of vehicles to travel in space, and also space tourism. I'm getting a site now on my email indicating that there's a special meeting taking place and having a special session involving space tourism, selling space tourism. So a hotel orbiting in space, imagine that. Got to have a rich uncle, though. It's going to cost a lot of money. So we're developing these here's the NASA's SLS, Space Launch System, SLS, going to the moon, carrying 4 astronauts. Orion is the name of the actual craft itself carrying the astronauts. Trouble is, the SLS is not reusable. On your right, you can see the SpaceX does have a reusable, and you probably saw this already on internet, maybe on YouTube or elsewhere, video, where it showed the rocket returning back to the Earth, back to some platform somewhere, maybe a floating platform in the ocean or something of that nature. Reusable. So a major portion of it is reusable. And Musk plans on having on board the Starship, he calls it, 100 passengers. Wow. We have to see this take place. It should be happening, I don't know how many years in the future, maybe 6, 7, 8 years possibly. Imagine that. Well, we'll see what happens. But all those things are becoming possible. Now, we can go back to the moon, as I said. There we go. We can set up a colony, outpost, maybe even a settlement. We have to build habitats. Might have to build them underground as well after a while. And we can use the material that's there, live off the ground, off the surface, off the Earth, well, off the moon in this case, so to speak, on the moon itself. And then we can carry on further, go to Mars. Same idea. The trouble is you're exposed to a lot of radiation. Meteors coming in. The atmosphere is not going to burn them up like they are burning them up through the Earth's atmosphere. And so you've got to be aware of those things, which is why it's better to go below ground if possible under those conditions. Set up some kind of habitat to live in. By the way, anyone come across what had been set up in the past? There was a program called Mars One by some Netherlands company that asked people to volunteer to go to Mars on a one-way trip. People volunteered. Yes, they volunteered. But now the company has gone bankrupt, so they can't carry out their intentions at this point. It was called Mars One. I don't want to be the one to go to Mars in that sense either, but to go to Mars, to come back, it takes what? A year and maybe 6 months or maybe 2 years? To go to the moon, it takes 3 days approximately. So if you forget something, you go back to Earth from the moon, not for Mars. Forget about it. So in any case, that's the idea. On Mars, we set up different habitats, scientific labs, and we could go mining on Mars. You can see here. Explore. Go to the moons of Mars, shaped like potatoes, because probably from the asteroid belt. Here's, you can see, Deimos, Phobos, the 2 moons of Mars. And we can do mining on these moons itself. Why not mine on the satellites of Mars? Okay, we're going back on our tour. But before we do, maybe we can go further. Maybe we can go beyond our area of space, really into deep space to further objects, galaxies, and maybe exoplanets around those galaxies. How do we do that? Well, like I mentioned before, we have to have something like a warp drive, and that comes in the BEC, Bose-Einstein condensate, 5th state of matter, necessary. We can do that. Or we can go through a wormhole maybe, which you'll see shortly, a rendition of it, not an actual wormhole in space, but artist's conception of it. And what we have to do then is warp drive. Boom. That's how we have to, we need that necessary to go to distant galaxies if we're able to travel at all. Otherwise, we have to travel by surviving generation after generation, passing on the baton on board the spaceship to the next generation, so that maybe the 6th, 7th, 8th generation lands where it's supposed to be going. But the other people have volunteered to die on board the spacecraft. Any volunteers? No? Okay. Yeah. Okay. So we're looking for a place to do this. And one of the best places to do this is to find a black hole. Maybe that's one way to do it. Find a black hole somewhere in space. And the black holes will emit different kinds of amounts of energy from its poles of a star maybe that has collapsed. Or maybe a whole region of stars. Like in our Milky Way galaxy, we do have a tremendously huge black hole. Most of the galaxies have interior black holes. I don't know if you realize that. But that's the situation in terms of galaxies containing black holes. So if we head to a black hole, and by the way, an image has been taken of a black hole. Don't know if you know that. Check it out on the internet. Recently. This is it. Now, why isn't it completely black so you can't see it? Well, because some of the material winds up moving around the edge of the event horizon, and as a result, emits radiation in the form of different wavelengths. And the telescopes, which were about, I think, 7 or 8, tied up together in a network around the world, picked up this image working together. And as a result, you have an image of a actual black hole. So it's something interesting to look at. So if we go into the black hole, we pass by up to the pass through the event horizon. We're being pulled in by this a point called a singularity, where the mass of a star or bunch of stars has collapsed, forming a very small point in the middle, which is hypothetical, of course, but also hypothetically may as well continue on this hypothesis. Started it, so we may as well continue on this pathway and think that, well, if the black hole were rotating and spinning, it might be bulging at the sides, and we can pass by this singularity and not be affected by it. And you might find that there's a wormhole in connection with the black hole, and if there is, it might be connecting us to another black hole or a continuation of the wormhole, so that we wind up someplace else in space. But it's got to be rotating. If it rotates, oh, by the way, we can see here that the artist is indicating that the wormhole can possibly connect 2 different areas of our universe, location, or 2 different points in time in our universe. Time travel could be involved in connection with the wormhole itself. So those are possibilities, hypothetical at this point, but still possibilities. Now, if we enter the wormhole or the black hole, let's say the black hole, if it's rotating, we can bypass the singularity, wind up on the left, going right through it. Of course, it'll be in some kind of vehicle. I'm not going to go, without anything surrounding me. But if it's not rotating, then what happens is you're pulled into the area of the singularity and you're stretched out like a spaghetti noodle, and they call that spaghettifying you. So you might be spaghettified then if you wind up aiming toward the singularity itself. Now, if you go through another black hole, you don't know what's in the black hole if you emerge on the other side. And we don't want to come across something like this, obviously. Darth Vader. What we want to wind up with, maybe, is something more beautiful. I mean, a beautiful area of a different location in space, or maybe a different time in space. Not Darth Vader. How do we do it? By developing a spacecraft that is capable of warp speed. And of course, in order to find out how we can do that, we go to those people who have already been on this warp speed vehicle. These are the different episodes of Star Trek. If you're a Trekker, you recognize maybe some of these. Or what you can do is maybe talk to somebody of wise nature that knows about the universe and the world. And about the only person that can help you is Yoda. But how do you get there? Someone has got to show you where to go. E.T. can show you. He can point the way. And so when he does, what happens is that our tour is over. To the stars. Ad Astra means to the stars, by the way. To the stars. our tour is over, returning back to Earth, to a place that's beautiful. Look up at the sky, at a dark sky site. Wow, the sky is beautiful. And as a result, our world is beautiful. That's it.
All right. Thank you very much, Carl. All right. So I noticed a couple people coming in during the middle of the presentation. So we're going to briefly go over the safety briefing that we had at the beginning. Right now, after that, we will be doing the question and answer session. I just ask that when you raise your hand, you keep it up until I can get to you, because I kind of lose you in the dark. I see the hand, I get halfway there, and then I lose you. But please do wait till I bring you the microphone so that our people online, because we have been live streaming this, can hear your question, because chances are, if you have that question, they have a similar question. So, like I said, the brief safety briefing. If you need to use the bathroom, that is the porta potty to my left. You're right with the red light. We do have the gift shop with a small museum attached as well. You can check us out on our website, uacnj.org. That's where you'll find a list of all our presentations, as well as a list of our member clubs. We do have a number of our observatories open. I think we have most of them. Except one I definitely see is closed. So after the questions, we will be able to observe the night sky through the telescopes. And with that, we're going to start off the questions with one of the online questions. And that was, why does the one side of the moon look to have so many more craters than the other?
As a matter of fact, they're not sure at this point, but they know something else. They know that the other side also is more massive than the side facing us, which makes them think that the moon may have been a chip off the old Earth, where something hit the Earth and knocked off a piece of the Earth, which the moon happens to be an example of. And there were two pieces chipped off, and one piece combined with the other, and as a result, you have one side that's more massive than the other side. That's their hypothesis in terms of how the moon formed. But insofar as the crater formation on the other side, no one's quite sure about that one. Maybe, well, it had to be exposed more, or there had to be, I suppose you have to be exposed more to have various objects from space crater the moon and cause the flow of the melted rock in the form of lava to the surface, making those dark patches on the side that face us, but not on the other side. Now, why on one side? They're still hypothesizing about that.
Right. Was there a question here from our live audience? Anyone? Oh, there's a hand. Just 1 second. Let me walk over.
Yeah, you had mentioned earlier that some of the planets that have multiple moons, some of them may be covered in ice, and others, I believe you were talking about the same planet, that some of them were hot and have lava. So why would a certain moon be covered in ice and another one be that hot?
Well, it depends where the moon is located. If it's located near a tremendously huge area of gravitational attraction, like, for example, Io, the moon, the closest moon to Jupiter, is so close to Jupiter that the gravity of Jupiter is tearing it inside out practically. So as a result, it's very, very hot due to the gravitational force on it, not because of the temperature of Jupiter itself, but because of the gravitational attraction. So not only does heat affect the heating of the moons, but also the gravitational attraction. Does that answer the question? Oh, okay, you're welcome.
All right. So our next question from online is, what is the furthest planet you can possibly view from UACNJ? And I know the answer. Do you know the answer?
Do I know the answer?
Yeah.
The planets that can, well, we can see 5 visible planets can be seen without a telescope. So I guess you can see those that are not visible to the eye, like Uranus, Neptune, and I'm not sure about Pluto. I don't think Pluto can be seen, but
The
I guess it can be by some large aperture telescope. But the other five are five visible planets by the naked eye. So obviously you can use a telescope to see them as well.
He is correct. We have seen Uranus and Neptune before. The seeing has to be just right. Unfortunately, tonight we definitely do not have that seeing. It's slightly hazy, but we do actually have stars overhead. So, yes, that doesn't always line up for us. But tonight it looks like we actually have that going for us. Was there another question from our audience here? Anyone? Bueller? Bueller? All right. So the next question was actually a comment when you were trying to figure out what best to call what some people call the habitable zone
Habitable, yeah.
on the exoplanets. Someone said the Goldilocks zone, where
Yeah.
it's not too hot, not too cold, not too close, not too far away. Which also is a good term because it doesn't say outright that you can live there, but it suggests that it shouldn't be that bad. All right.
Thank you.
Yep. Looks like most people are actually heading out to view through our telescope. So I want to thank you guys again for coming out to our presentation. For everyone who's come out here to our site and watched online. Like I said, please do check out our website, uacnj.org. Also, our socials, Facebook, Instagram, Twitter, as well as our Discord server. Always check us. You can check out our past broadcasts on YouTube. We keep all of our past presentations up there, so you can always go back and look and just drop us a like and follow because it also allows us to know that what kind of content you guys want to see. And with that, have a good night, everyone.
Thanks for coming.